Recording live, straight out of Narawaya. Here's Maurieo. Hello, hello. Regarding how to calculate the boundary bearings and distance, particular little worksheet that I'd given them. So what the worksheet does is it follows through from a traverse and then the radiations out to the boundary pegs, and then calculates the boundary bearings and distances. So before we go to the boundary bearings and distances, it's probably necessary just to show how the traverse worksheet pans out. So what I'm going to do is I'll just get rid of my calculator there. I'll just go over to the big screen, of course, so that you can see that. So here's the big screen. I'm sitting right in front of the traverse spreadsheet, and over here is the plan, and here's my calculator. So one of us has got to go. It's either me or the calculator. I think it'll be the calculator at this time, and we will just minimize the calculator and bring it back at a later date. So first up, we have what is called the traverse block, and that is we've started with a known coordinate at ITO1. I don't know, I haven't. Oh, there it is. It's recorded on the sheet there, 802.147.98, and I always hate doing these things, and you find the mistakes as you're going through them. Usually about the fifth time. And for there, that's the coordinate there, 87217 for iron tube. Iron T stands for iron tube 01. So, and then we get the bearings and distances going in the correct direction around. So 420330, 240.47. So we can put those in. 135.53 and 127.28, 212. Now I've actually kindly put them on the actual correct distance. If you start from 1 to 2 to 3 to 4, and you put them in. Now the next thing then to do is to what we call run them out. Now I've done them using a spreadsheet here, and I'm just going to click on that spreadsheet, and you can see the formula that to get the northing, you take the cosine of the bearing and then multiply that by the distance. So I just click on here, I think it'll show, well, perhaps not. Cancel. What's that showing? Oh, the arguments of the function. Perhaps that's not what I wanted. Oh, there we go. Now, the way that I've done my traverse sheet is I get it so that I put the degrees, minutes, and seconds in separate cells. I find that makes the calculation a lot simpler. I don't have to split them up. And here you'll see that I've put them in there and divided by 180. Now, one of the vagaries of Excel, Microsoft Excel, of course, is that it calculates everything in radians, not degrees. So we've got to convert it to radians. So that's why I've divided by 180 here. And that will convert the degrees, minutes, and seconds to radians and multiplied by pi. So the cosine of that gives us, and then multiply that by the distance. And that will give everything the correct sign. Okay, so this first one here from ITO1 to ITO2, you'll be going. Oh, you can see that. That's good. Oh, can you see it in the? I think you can. Yes, from ITO1 to ITO2. You'll see that that is going first north, then east for the components. So there's a number of ways of doing that on the calculator. I always just show, and the same for the easting, except that's the only difference is the sign. Now I round all these to 2 decimal places so that everything calculates out so that we don't have any stray arguments from the continued accuracy of the thing. So everything's rounded to 2 decimal places to make everything fit nice and tidily into the spreadsheet format. So that's what's going on there. Now, because you have to do this in a test or an exam, I tend to just show you how to do it right from the first basic one. So I'll just put that up there. I just want to see if no, it's going to stay there. That's really good. And I'll move it a little bit closer. So first of all, if you want to put in 420330, here we're testing out how this is going to work. So let's have a look at this. And as I say, I'm looking over to one side because I'm actually not looking at the calculator by the look of it. But anyway, I'm looking over to my second screen where the calculator resides. Perhaps if I put the no, I'll leave it how it is. So 42, and then we push this button here, degrees, 42 degrees. 3 minutes, 3, and push the button again. Oh, sorry, delete, delete, delete. So what we need to do is first of all take the cosine, and then 42 degrees, 03 minutes, 03 minutes, and well, 30 seconds in this case here, 30 seconds, 30 seconds. Close the bracket. And then multiply that by the distance, 240.47 equals. And we get 178.54. Be careful to round it appropriately. You can set the thing here to, if we go to mode, no, if we go to shift mode, shift mode, and go to 6, which is fix 6, and we'll fix it to 2 decimal places, you can see you get 178.54. So that's all pretty good. Now we'll do the one for the sine over here. Well, I'll just do one over here that gives us slightly, just to show you how you can get negative, how it will give a negative answer. So I'll do this one here. I'll calculate the sine of that one there. So just all clear. Well, I'll do the whole thing because you can actually do this here, which is quite good as well. So all clear. Let's go. I'll do the cosine first. Cosine 212 degrees. 42 minutes, 42 minutes. Close the bracket. Times. Now that distance will be the 194.75 equals minus 163.88. Now you can do this using the polar and rectangular buttons down here, and it'll do them both together, but I initially show people how to do it from basics, from the basic, from sine and cosine. So you can use that one there, but I think the sine and cosine's easier to remember. Remember cosine for northing and sine for easting. So it goes in alphabetical order. Well, the northing first, so cosine for north and sine for easting. So we've done the cosine there, but with this particular calculator, what we can do is just come back through, and we can just delete the cosine and put in the sine, and then push equals minus 151.21. So you'll notice how that doing it that way, it gives you the sines and the cosines. So that's all very well in there. All right. So this is the Trevor sheet. This is not about the Trevor sheet. It's really about how to, I should have said that in the beginning. Well, really, the question was how to work out the boundary bearings and distances. Oh, I really want to clear that there. I'm just going to clear the contents of that in readiness. Insert editing. Oh, I might have to push this up here so that I can find where the clear is. Clear contents. Oh, I think that's all right. Yes, and then we'll go. Oh dear, that's mucked everything up. Okay. Oh, perhaps I should have done this. Okay, so that's just gone through how we can do that. So the next little, oh yes, we're in here. Okay, so so we go through our Travis and we get our add up our northings and get that misclosed there. Add up our eastings and get that misclosed there. And then we can work out the Bowditch adjustment. And I've got that here as well. So that's rounded to 2 decimal places. And we just obviously take the total distance, or take the distance divided by the total distance and multiplied by the misclose. So that over that times that will give you the there, and we round that to 2 decimal places. So if we go, you can see that one there, you see that one there, you'll see how it goes there, that one there like that, and this one here, there like that. And they should add up and be equal. Same over here with the eastings. Same deal. Same deal. Same deal. Note that the dollar signs means that it always goes to the same, like $H, $12. It'll always go to H12. Okay, whereas the other ones, $East, $12 is $E12. Oh yeah, that's E12. H12. Oh, where's H12? A, B, C, D, F, G, H. Oh, H12 is that one there. So the only real variable one is E9. There, as you can see, that's the variable one. So they're all multiplied by the same thing. And that's what the dollar signs does. So that everything balanced out. This should equal this. If it doesn't, you've got to slightly sort it. And then it's just a matter of calculating the coordinates, which are just very simply the one above plus the difference plus the adjustment. Same here. You'll see there. One above plus the difference, and so on and so on. So yeah, that's all done. But because my students have to do it in the exam, they would have to run it all out, add all these out, calculate the Bowditch adjustments and so on. Now then the next step is to, so just over here, we've got our diagram here. So we've been through, and now we've got networked coordinates. So they're the highest accurate coordinates of 1, 2, 3, and 4, and back to there, and they're all closed off. Now we do the radiations. They just hang out there. They're all hanging lines. So that's the radiation. So they're just measured. They don't have any checks on them when you measure them. So quite often we'll do an independent check. We'll do a different way of checking the bearing and a different way of checking the distance to get the independent checks. So, and once we've established everything on a Travis sheet, everything on a Trevor sheet. I'll just drop me down a little bit. I'm not think I'm that significant in the picture of things. So everything on a Trevor sheet, so the first coordinate here originated from the thing there, and we ended up with 4 coordinates. Now these coordinates here track downwards. So you'll see here, IT1. So we've got from IT1, remember that top space is always blank in every block. So this radiation block, top space is always blank because you're going from IT1 to PEG1. So that's 26717. There's that 5133. Now, no adjustment in this. See, this one, its accuracy comes from its network. This one, no adjustment. So you don't have to worry. So we just work out the northings and eastings and add them to the coordinate for IT1. So we're just going from there to there, and that gives us the coordinate of that. And similarly, PEG2, PEG3, PEG4. So obviously these ones here are all from up above. So it's just a matter of, I don't know whether I've done it. I have. See, I've just put plus J6 there. And you'll see that that's IT1 plus J6. And here, plus K6. It'll copy text as well, exactly as it is. And then it's just a matter of working out the north. This one here, J9, and that's IT04. Okay, so what that does is now generate new coordinates for PEG 1, 2, 3. Oh, that should be PEG, not PRG. Okay, so that's generated new coordinates for those. Now, what we want to do is we want to calculate the bearing and distance from PEG 1 to PEG 2. Now, this is the paper one here. So I've got the answer here. I better see how good I get. Okay, so what I'm going to do is, so we don't have all, these are called inverses, boundary lines, joins or missing lines. So we don't have any bearings. We're actually going to now calculate the bearing and distance from PEG 1 to PEG 2. So how do we do that? Well, we always start with the information that we have. So we have the coordinate of PEG 1, obviously. So that there is just plus that one there from PEG 1. Yeah, and then we can actually just copy these across because they're in the same relative position. So there's PEG 1, and then this is the coordinate of PEG 2 plus PEG 2, and that'll go in there. And we know we've got that. That's all information, you see. So these are called inverses. Normally we're going in this direction, but in other situations, no. So what we're doing here is we want to calculate the bearing and distance. Here we've got to go back, so it's using the inverse. So now it's a matter of calculating what the difference east is. And that quite simply is plus that minus that. We just do that on our spreadsheet, or we can write it down on a bit of paper. So if we take this value here and we add 203, it comes to that. And that's always pays to check that. So then plus that minus that. And we've got 254. Now that's going north and east, which is correct. So now we've got to work out the distance. So what I do at this point in time is I usually draw a little diagram. So I'm going to try and draw a little diagram here. I think I might have to go full and go to shapes, and I'm going to draw a little arrow. So I'm going to start with the northing here, and I'm going to go northing there like that, and oops, I want to go northing in that direction. So I'm going to go 254, okay, north. All right, and then I'm going to do another one, and I'm going to go from that one, and I'm going to go east. But it's smaller, so not quite as much, so probably something like that there. Okay, now for my final one, which is like, so I started here, up here, across here. So the direction of the actual one will be from here to here. So that's my little triangle there. And this will be my easting here. Sorry, this will be my easting, 203.77. And this here will be my northing. So I want to calculate the bearing round, and that's that angle from north, always the angle from north, and the distance. Now you can see that the distance is going to be straight Pythagoras because this is a thing. So let's do the distance first. We want to round it to oh no, we don't need to worry about rounding in this case because this is the answer. So what we want to do is I'm going to put down first of all, I'll square both of them. So it's plus that there, raised to the power of 2, plus that there, raised to the power of 2. And then I've got to take the square root of that. So I'll just put a bracket around them. And I'll just carry on my merry way like that. And then I'm just going to raise that to the power of 0.5, which is the square root. So that gives me a distance 325.99. Now, I know I've said on many occasions, if you're sitting in front of a spreadsheet and you've got your calculator and you're typing numbers in, you're doing it wrong. And this is true. But I'm just using this as a quick method here of showing how things can be done on the calculator. Now, I don't think the taking the square root one's that difficult, and the next one would be, as I haven't quite got a sorted out, a way of doing the next one on Excel. So I am going to use my calculator. There's an exception to every rule. In this case, this is it. I make the rules, so I guess I can make the exception, I would expect. But anyway, let's see what happens. So we need to work out the bearing. Now, that's going to be the tan. Okay, all right. So it's going to be the negative tan. So it's going to be shift tan. And then it's going to be the easting, which, of course, the difference east, which is 203.77. And that's going to be divided by 254.46. Okay. I think that's good to go. Yep, I'm happy with that. Okay. Enter, and that gives us 38.69. Now that's degrees and decimals, and that's this angle in here. Now that's the angle we want because bearings are measured clockwise from north. So I'm just going to convert that to degrees, minutes, and seconds. 38 degrees. It's going in here. 38 degrees, 41 minutes, and 15 seconds. There you go. And let's drop that down there. Let's put this back to that side. And there we go. Oh, 38, 41, 20. So I've rounded that up to the nearest and 3 to 32600. So reasonably close. Might be a little bit of rounding issues there, but generally that one's all right. So let's do a couple more of those. If you think you got it now, you could carry on. Obviously, you've got the answers. So I'll just do a couple more of those and see how we go. All righty. So what we want to do now is go from, I'll just check a little bit here. I think I got, oh yes, 3841, 1325.99. For some reason, I rounded it up, but, 0.99, I think I've got. Yeah. Okay. All right. So let's just going to be peg 2. So that's pretty simple. Control C. Let's just put that in there like that. That didn't work, but I think, no, delete. So that's fine. Let's just go plus peg 2. Okay, I see it was copying a relative formula. That's good there. It pays to check there, and plus peg 3. And that goes in there. Now, one of the beauties of spreadsheets, of course, is you can just copy these down here because it's exactly going to do exactly the same. And there we get minus 153.14 here and 191.24. And this here is going to be exactly the same as well. Okay. Now, 245.00. What is going to be a little bit different is the diagram for this one. So let's blow it all up here, and we'll get our calculator out ready as well. Okay, so right. So we're going, this time we're going to go south 153. So that's insert shapes. South 153, so I'll put it maybe here. Oh, that didn't. Okay, we want to go there like that. So that's gone south 153.14, like so, and then we'll put another one in, and that one is going east. The negative indicated south and positive east, and 191.24. So you'll note that that's bigger than 153. That just helps you to get a bit of an idea. Okay, now the actual finish one that we want, of course, we started here and we're going to there. Okay. Now our tan, we can calculate this angle here. I'll just put a little text box in there so and I'll just call that X like that there. I'll just click on that. I don't like those boxes around things. And we'll format the shape. Calculator out of the way. No line. Oops, that didn't go so well. Format the shape. Okay. Oh, no line we want. Okay, and we'll close that. There. Yeah, so that's X in there. I can just. Oh, it's down here. Put it in there like that. Okay. Oh. A little bit this way. Okay, so that's our angle X. Now we can see there that we're going to go shift tan to the -1, and it's going to be this here, which is the easting, 191.24. 0.24 divided by, now we don't worry about the negative signs when we're doing it this way, then, because it doesn't matter. It's just the distance. In fact, the negative signs could well muck it up. 153.14 and the bracket, and there we go, equals 5131. Now this is this angle here, but the bearing that we want is always the angle from north. So we want to go 180 minus that answer. Okay, so what we then got to do is 180 minus answer equals, and then we'll pump that into degrees, minutes, seconds. So we get 128, 41, 13. I'll put the real one. I might have rounded it. I'm not sure. 128 degrees, 41 minutes, 13. So in real life, I would probably have rounded that to 128, 41, 10. So let's get the calculator down there. Let's bring this back here. And what did we get there? 128, 41, 13, 249. So that's my calculation there. And then I'll just go up to here on the diagram. And yes, 128, 41, 20. So I've just rounded it to the nearest 20. Oh, is that right? Oh, I don't know. Well, 4110 or 4120 probably doesn't matter. Oh, yes. I think in this case here, the instance that this, so that's why I've gone in keeping them all the same, both sides the same, and so that will depend on the other one. So let's do well, we'll do all of them, I guess. So right, so now I'll just very quickly do peg 3, which is in there like that, and copy that across there. So we'll start to, as you get more experience, you speed up. And then this is peg 4. I haven't had anyone in the chat for this one, so yep, that's not a problem. We're just going, but it'll go out live. So this is peg 4. That'll just truck across there. Oh, no, it won't. We'll just copy that across there like that. Okay, peg 4. Now this here, Control C. This will just copy down to here, like so. Okay, and then so what we've got to do now is do the little triangle. Well, it might be interesting just to. Oh no, I don't think I can do it over there. I probably could. Oh, I'll stick with what I know here for the moment. I didn't practice that one beforehand. So yeah, alrighty. So let's draw the little diagram. So I'll make this big here. Yeah. Oh, I can draw the diagram out over here. So I'll make this one big here, and we'll go insert shapes, and this one here. So first of all, for this one, we're going negative north, which is minus 254.46. So negative north, which would take us like that. And then we're going negative west, but not as much. So just a little bit less. I'll just go like that, which should, okay. All right, so there's our angle, our line, or our resultant vector, our missing line, our boundary. It's going to go from there to there. And then we've got here, copy and paste. I don't know where there's the X way up there. So we'll just put it, and that's our little angle there, the X in there. Okay, so we get out our calculator in this instance here. So this is our angle here. That's the angle in there that we want, and we've got our bearing from there. So we're going to have to add 180. So, I mean, we could maybe go a little, I'll do it this way first. So shift tan to the -1, and we want our there. So that's 203.78. Doing it this way, you don't have to worry about the signs because you just want the absolute distances. 254.46. And that should be divide, not plus. Divide. Oh, that's times. Divide. Yep. And back to here. I'm pushing those buttons using my keyboard. Just there, and equals. And that's 38.69, which you'll notice was the same as for the first one that we did up here. But this one, obviously, it's 180 degrees different. So we've got to add, and our bearing we want is from here. So we've got to add 180 plus equals. And then we get 218.4120. So that there's 218 degrees, 41.20. And you'll see that that's 180 different to that one because that's how they should be because it's a rectangle. And you'll see here, that one's 325.99. This is 326. So generally we do our calculations, or I do my calculations, and I then put the final answer. So that will be why I've made that 326, same bearing, same distance, because they are a rectangle. So you don't want to have these niggly little errors in there, and we know that that's good. So we do get a bit of error. Any error that was in the traverse obviously makes its way out to the outsides there, to the boundaries. Okay, so let's do the final one, and just to complete the set. So that's plus peg 4. You can do this on paper. A lot of this, I'm just doing the simple stuff on the spreadsheet. So by all means, have a go on the spreadsheet, but in a test or an exam. And now we're going back to peg 1, which is, well, we can go to any one of them. Always probably pays to keep with the actual original peg 1 in terms of, the first time it appeared on the traverse sheet. Okay, and then this here, just Control C, that comes into there. Oops, 9. So again, and these are possibly the little errors that came in 2 there. So 244, so we're going to make that one 245. So it just remains to calculate this bearing here. And so one should never assume a bearing, that it's how it is. Should always calculate it because it proves the accuracy of your work. And so for this one here, right, let's grams insert. So we're going 153.14 north. So I'll put that up. Oops, that didn't shapes. I'll put that here. So here we north. Okay, and then we're going to go west, and we're going more west than we are north. So insert shapes. So we want to go more west. I'll just put that right over there like that. And then our final one obviously goes from here Oh. Here it is. We'll just put that over to there. So that's our final resultant vector. And X, copy. Paste. Here it is here. And this is our little bearing that we're going to calculate there. Okay. Oops. That's our little bearing that we're going to calculate there. And so, all right, so let's get the calculator out. So it's going to be, we're going to have to subtract it from, teach yourself, as I said earlier, to use the pole button and the rectangular button. And I have done a video elsewhere on how to use those buttons. So if you want to go to that next level, you could search that video out. I might put it in the description below this video when it comes out. So let's go shift tan to the -1, and we want the that's the easting, so that's 191.23. 190.23 divided by, and I would recommend using the northing, so it's adjacent, tan is opposite over adjacent, and that's 153.14. I would recommend during the drawing always, because it gives you a good indication of both the scale, close the brackets, equals 51.31, and that's our answer, but we want to subtract that from that, so it's 360 minus the answer equals 308.69, and then we make that there 308.4117, and we put that in here. Not like that. 308.4117 and 244.99. Okay, so that's that little spreadsheet done. The other thing to remember is that Travis sheet, these Travis sheets are also done on, oh, someone's given me a like right at the beginning. Thanks very much for that, whoever you might be. That's pretty awesome. And always draw the little diagram. It gives you a bit of a thing. I lost my train of thought there. For your calculator and what have you. Yeah, all pretty good. Oh, in New Zealand, yeah, these Travis sheets, pretty there. Oh, yes, we do have software that does them for us, various Travis programs and things like that. So the purpose of doing them in a course or that is to have an understanding of the northings and eastings and how it all relates back to trigonometry. And that background always helps. It's that's in my opinion, that is what defines a professional. It is someone that has all that background knowledge. So they just not only can they do the job, but they know why they're doing it and they understand why they're doing it. It's that whole thing, you know, an amateur does things until they can do it. A professional does it until they never get it wrong. And that big part of experience in this area is sort of, well, I won't say never getting it wrong, but getting it wrong right 99.999% of the time as a professional. The amateur might get it right 95% of the time. And that is what professionals employed, finding the errors that amateurs have made. So, yes, oh, getting a bit philosophical there. Anyway, so let's, well, I just put the calculator in there. That's a calculator emulator that I found online. It's pretty good. And I'm running a little program with it called Always on Top, which is a free downloadable little, very simple little project. I just spacebar and that puts the whatever window you're working with always on top. So now we're in this window here. Okay, so there it is. Now you'll also notice that I rounded the final bearings and distances, rounded them out, and that's very common. And I always try and show them on a diagram so that we have a diagram showing exactly what we've got. So there, I'm going to wind this up from now. I'll just say, put something in the chat so that it does show up, so people can see that they have the opportunity to chat for these live when I go live doing these survey sort of things. So that's all very well, and we'll just go back to the beginning. And so here we are at the end. That's quite a bit of a way to go through, but I thought it was necessary, and I'm sure that people will work their way through the to the bit that they need or the bit they don't understand. So that's the purpose of these. If you have any issues, any troubles on that, get hold of me, contact me, and I can go live or see what I can do. But yeah, we'll see how these things sort out. But yeah, I'm always happy to help if I can. I do know my limitations, and sometimes I am very busy, so I'm not able to help in a particularly timely fashion sometimes. But you know, if I can, I will, and if I can't, I'll try and let you know. All good. Cheers. Let's end this stream right now as we just sign off. All good.